Okay, so 5.8. So we have two examples. Determine the value of x to the nearest tenth of a centimeter. So that's this. So 5.8 is mostly just having a couple triangles put together. Okay. So 320, it's not the same question, but it's just to give you a visualization. So we kind of have a flat triangle here, and then one going upwards. Okay. So we have to find x here. So let's work a little bit backwards. So we have this one triangle here, and it might be in the glare a little bit. Okay, so we have this triangle here. The only piece of information that we have on this triangle is one angle. Okay, I just want to note what type of triangle. Did I start it? I think. Yeah. Okay. What type of triangle is the one up here with the x? Aaliyah? We have a right angle triangle. Okay. So when we have a right angle triangle, we can use SOHCAHTOA. Okay, so sine, cos, or tan. But in order for it to do that, we need one angle and one side or two sides. Okay, so we need two pieces of information for this triangle in order to find x. Right now, we only have one piece of information. We only have the angle, okay, and we don't have any sides. So we need to have at least one side, okay? So we can't do anything with this triangle, okay? So now we have to look down at the triangle here at the bottom. The triangles have one piece in common. They have this side here, okay? So they have a joining side. So what we want to do is try to find this side here, okay? Since it's shared between the two triangles. So if we can find the bottom side, then we'd be able to find the x afterwards. Just take a stroll outside. Walk around. Enjoy the weather. Okay, so we have this side here that joins between the two triangles. I'm just going to draw this one bigger. Okay, so it looks something like this. So it has two ticks here. We have a 70 degrees, and then we have a 27 centimeters here. Okay, so I'm just redrawing this triangle over here. I'm going to give a letter to that one. So this is B, B, and let's say this is C. Okay? So right now we only have one angle, one side. Okay? And this is not a right angle, so we need a little bit more information. We either need two angles and a side, or two sides and an angle, and then we could pick if it's going to be a sine law or cosine law, okay, or three sides. So I have two pieces of information. How do I get another piece of information from this one? So,
the side lengths have like I forget what it's called, but they have like those lines that indicate that they share the same side length. So
perfect.
The side length from B to D will be 27 as well, so you can do cosine law.
Excellent. I know what you were going to say. Okay, so we have these little ticks here. I don't know what they're called either. I just call them little ticks. So that indicates that this side is equal to the other side. So they're equal. So if this one's 27 centimeters, then this one is 27 centimeters. Okay, and then that was Isabella. She went on to say that we need cosine law. How do we know it's cosine law and not sine law? How do we know? Adrian? Exactly. So we have the angle that is contained. The angle is contained with the two sides. Okay, so we have cosine law. And then you can look that we don't have this angle. Oh, actually, we could find these angles, but we don't need to know that. If you did 180 minus 70, it'll give you 110. And since it's isosceles, these are both 55 then. But that's not going to help us. We don't need to do that. We need to find this side here, because that's the side they share. I'm just going to call it Y. So this side, they share this side here. Okay. So let's use cosine law. Okay, are we using the first formula, which is for the side, or are we using the second formula, which is for the angle? The first formula, yeah, because we're solving for a side. So it's d squared, but I'm just going to call it y squared for now. And then we have c squared plus b squared minus 2cb cos of y. Well, actually, I should call it d. Let me just call it. It doesn't matter which you put C or B first. So it's not alphabetical for mine, but it wouldn't matter. Okay, now we're going to substitute the value. So side C. So side C is across from angle C. So this is side C. And side B is across from angle B. So I'm going to call this D. And change this to a D. Okay, so 27 squared plus 27 squared minus 2 times 27 times 27 cos, and angle D is 70. So again, like the previous lesson, do the first two terms, square it, and then do the second piece together, and then we subtract them.
Sir,
Yes.
I was just wondering, for like, in a situation like this, if your calculator is able to like put the entire equation into it, would you prefer us to, like, will we not get full marks if we just put it?
If you move from this right to the answer, at least give me one more. Maybe get the answer here and then show me the square root. That's fine with me.
So if I were to just put the entire equation in, and then I can show you the answer and then the square root and
Yeah,
then the answer.
that'd be okay with that.
Okay.
That would give me three. That'd be give me 3 steps. Yeah, I'd be okay with that. But just be careful. What's 27 squared?
729.
And then again, it'll be 1458. I don't know why I use my calculator for that. 1428 minus, sorry, 58. 2 times 27 times 27 times cos of 70 gives me 498 point. I'm just going to use 4 decimal places. It's up to you. I would suggest keeping 4 decimal places. Not so much for the sides, but for the angles. Like it just gets a little bit more accurate. Okay, so this one was not a double negative this time. It was just a single subtraction. So 959.3346. When you get to grade 12, I tell my students to carry 4 decimal places for everything. Okay, it's just the more accurate you'll be with your answers. Okay, so would 959 centimeters make sense for this triangle? No, that means I forgot the last step, which is, Declan?
Square root.
Square root. Okay, so we're going to square root the d squared. And we get 30.97, does it tell me? 1/10 of a centimeter.
I
So
just rounded to 31.
it will be 31, yeah, because 30.97 rounds up to 31. So we get 31 centimeters. It is said to round our last one, so if you didn't round at this step, that's fine, as long as your last one is rounded. Okay, so we found the side that they share, so it's 31 centimeters. So this whole section of 5.8, it does all the different triangles that we've learned. So it does right angle triangles. So we're doing SOHCAHTOA. Then you'll have triangles with sine and cos, or sine law or cosine law. Okay, so you have to pick out which ones you'll use. Okay, now we are good for the right angle triangles. Now we have an angle and a side. So we're going to use SOHCAHTOA, the acronym. You guys can list out the G and F if you want to. Okay, what's given, what's needed, what's the formula. Okay, what I showed you. What's given, what's needed, what's the formula. Or you could just label the sides and see what we need. So I'm going to label the sides first. Okay, right angle triangle, what side do I always label first? Which one did I label first? The hypotenuse, good. So our hypotenuse is across from 90-degree angle, so this is our H. What's the second one I label? Maddie, the opposite, okay. So since we're using the 27-degree angle, we will be, because that's the only one we have. We're not going to use 90 degrees. So across from 27 is 31. This is our opposite side. And then our last one will be our adjacent side. Okay, using your knowledge, what formula are we going to use? Sine, good. So we're going to use sine. So we have the opposite side. We need to find our hypotenuse, so that's O and H, and we have the angle. So O and H, which is sine. So sine theta of the angle is our opposite over our hypotenuse. So we have sine of 27 equals our opposite, which is 31. And we're looking for our hypotenuse, which is x. Isabella, you had it as well, thank you. Okay, so we isolate for x. When x is the denominator, I showed you a shortcut. What was you got last time I asked, right? Adrian? You just switch them. Okay? The correct way is multiply by x over here and then divide by sine 27, or you could just switch them. Okay? You swap the places. You get x equals 31 divided by sine 27. And it says to the nearest 10th of a centimeter, so I get 68.28, which would give me 68.3 centimeters. Did you guys get the same?
Yeah.
Yes, okay. Just make sure you're rounding. Just give you guys a minute. Any questions? When we have the test next week, you will have a question that looks similar to this. So you definitely have one that has multiple, like you'll have multiple questions. We have two triangles. Even the homework today, number 7, that's an option. There was 2 questions in the homework yesterday with multiple triangles, so make sure you practice them. Okay, last one. Okay, so Doug is looking at a cliff. Let's draw a cliff here. Here's Doug. He's got spiky hair. He determines that the angle elevation to the top is 54 degrees. Must be a pretty smart guy to do that. So from here to here, so remember the angle elevation goes from the horizontal up to an object. So from the horizontal up is 54 degrees. 50 meters away from Doug, Gary estimates the angle between the base of the cliff himself and Doug to be 26 degrees. Whoa, hold on. 50 meters away from Doug, Gary estimates the angle between the base of the cliff himself. Oh, I know which one I did. Let me I'm sorry, I have to draw it different. Sorry, I thought this was something else. Okay, so this is my cliff. My apology, guys. And I know I pulled this from an example here. If you guys could look at page 333, number 7. I'm drawing something like that. I'm going to be drawing something along those lines. Okay, so I have a person here. This is Doug. And now we have Gary. He's got wavy hair. Okay, so let me do that again. Okay, so Doug is looking at a cliff. So again, if you look at page 333, number 7, this is what it is, and we assume that a cliff will make a 90-degree angle. So the angle elevation from him to the top of the cliff is 54 degrees. Okay, so then 50 meters away from Doug. So this is Doug. This is Gary. And they're 50 meters away. He estimates the angle between the base of the cliff himself and Doug is 26 degrees. Where is that 26 going to go, do you think? Adrian? You're thinking here? So the base himself and Doug. I would say the base himself and Doug. Should probably put it here. If it said himself, the cliff, and then Doug, then I would probably say it was here. But let's go with this part here. Because it says the cliff, himself, and Doug. So I would put the 26 here. But that's what I first thought. I was thinking, Adrian. I haven't done this in a couple of years, this question. While Doug estimates the angle between the base of the cliff, himself and Gary, to be 70 degrees. Okay, so this is 70 degrees. Between the cliff, himself, and Gary. So that'd be 70. Ooh, the wording's tough on these, right? All right, so what is the height of the cliff? Okay, so that's what we're looking for. So again, I try to draw something similar to page 333, number 7. You can see two guys looking up at a princess. Okay, so same idea. Okay, so this is the cliff. We have two people looking to the top of it. Okay, so let's work backwards. Let's work backwards. So we're looking for H. So there's two triangles that H is connected to. Okay, one of the triangles has no information, and the other triangle has one piece of information. So which one do you want to use?
One with one piece.
Yeah, we want to use this one, okay? So, but we have this triangle, we only have one piece of information, so we can't use it yet. We can't use it yet. So what we want to find then is, I'm going to call this X. Okay, so this side here joins the bottom triangle and then the triangle going upwards. So they share one side. So if I could find this side here that connect the two triangles, then I would have two pieces of information, and then I would be able to find the height of the cliff. Okay, so we have to use the bottom triangle. What information is given in the bottom triangle? We have two angles and one side. Two angles, one side. What law, and this is not a 90-degree angle, these ones will be because it's along the cliff. Which one requires two angles in the side? Leah? Sorry? Sine law, good. And I think Isabella had it too, and Adrian as well, yeah. Sine law. Okay, so two angles and a side is sine law. It doesn't matter what two angles, because we can always find the third one. Okay, so in order for me to use it, I need to have a corresponding angle and side. So this side, I don't have the angle yet. So let's determine this angle here. So it would be what?
84.
Sorry?
84 degrees.
How'd you get it?
180 minus the US.
Good, so 180, subtract 70, subtract 26 is 84 degrees. So 84 degrees. So now we have our corresponding angle and side. And now I want to find X. So now I have to find X. What angle do I use in the sine law? Actually, let me write it out. I don't have any. I'm just going to call this A, B, and C then. This is A, B, and C. So let's do it this way. That's right in the glare. Just labeled it A, B, and C just so we could start substitute stuff into the sine law. Okay, so we have sine A. So sine 26. Okay, side A, we don't know, which is X. So that means we have to use that one. Okay, let's go over B's. So we have B is 84. And the side B is 50. And then we have C, which is 70. But we do not know side C. Okay, what two fractions in the formula am I going to use? What two fractions? 1 and 2, 2 and 3, 1 and 3.
1 and 2.
1 and 2. Good, because we have the two pieces of information for this one, so we have to use this one. And this is the x. We don't want to find c, as it doesn't help us because side c is over here. So that doesn't help us. So we're going to use these two fractions. So that's cross multiply. Okay, so I told you two fractions and an equal sign in between. You could cross multiply. Start with the letter. So x sine 84 equals 50 times sine 26. And this value at first and second. Okay, what do I do now? What do I do now, Adrian? Yeah, so divide by sine 84. And now let's answer it. We do not have to do an inverse because we're not looking for an angle. So 50 sine 26 equals divided by sine 84 gives me 22 centimeters. It's 22.03. We'll just use, so x is 22. Give you a minute. And now I'm going to erase this part so we no longer need it. So now I'm just dealing with this triangle here. Okay, and assume that the cliff is 90 degrees. So I said, unless it specifies otherwise, a tree, a cliff, a pole, building is 90 degrees. Okay, unless they say it's leaning. Okay, so assume it's all 90 degrees unless they mention otherwise. I don't want to call this H. I'm just going to erase the H for now. We're trying to find the height of the cliff. Okay, so we have a right angle triangle. Now we move to SOHCAHTOA. Sine, cos, or tan. Label our three sides. Which one do we label first? The hypotenuse, which is H. Okay, crossing the 90. The next one. Adrian already says we're using tan. Okay, but I'll get there. Okay, opposite is where? Left or bottom? Left, because it's crossed from the 54. So opposite, and now the bottom is A. So what do we have? We have our adjacent side. We need to find our opposite side, and we're given the angle. So it's O and A. So you're right, Adrian, and we're using tan. Okay, so our opposite, and we have our adjacent. So tan 54 equals our opposite, which is, say, y in this case, over our adjacent side, which is 22. Okay, what do we do now to solve? only if the y is on the bottom. So we only swap them if the letter is in the denominator. Okay, so it's not the denominator, it's the numerator, so it's actually easier. Adrian? Yeah, we just multiply here. So multiply them. Since you're dividing by 22, we multiply by 22 on the other side. Okay, so it's y equals 22, 10, 54. Okay, so if the letter was in the denominator, then we just swap it. The letter we're looking for is in the numerator, so we just multiply. I'm gonna get 30.28. The sound, it says the round, yes, round to the nearest 10th. So y is 22.4. I would assume it's meters, yeah. Meters. Sorry, whoa, not even close. 30.3 meters. Sorry, I was thinking about the previous question when I wrote 22. I think that's it for the lesson. Do not do 7. If this was a regular school year, I would assign 7. Take that out because it's actually a lot harder. Even though it looks the same, it's missing, it doesn't give you any angles in the bottom. And you end up having to make 3 equations and then solve for different letters. So do not do 7. Okay, so it's just 3, 4, 8, and 8. 3, 4, 8, and let me see what 11 is. And 11. Okay, so aren't too bad. 3 has 4 questions. Another, so it's 7 altogether. Okay, so again, do not do 7. So it's page 332, 3, 4, 8, 11. So again, if it was a regular school year, I would have 7, and I would also throw it on the test, and it would be like an 8-mark question. But I'm not going to do that this year.